This is section 7.1. We're comparing two means. So as always, look at the objectives. Pause the video to look at the objectives. And then we want to start by reading this excerpt from an article abstract. So I have just copied this over because I do want to give you exposure to seeing how other people word it in practice. But we have the research with humans and other animals suggests the walking benefits physical health. Okay. And they said, well, maybe we should look at how much zoo elephants are walking. Okay. And so they're doing a study to examine elephants and walking. Okay. And so they said that their study was the first one to measure the mean daily walking distance of elephants in North American zoos. Okay. Determine factors that are associated with variations in walking distance and testing for associations between walking and welfare indicators. So they used anklets equipped with GPS to measure the outdoor daily walking distance in 56 adult female African. So there were 33 that were African and 23 that were Asian, so total 56 elephants housed in 30 North American zoos. They collected 959 days of data. They found that elephants walked an average of 5.3 kilometers per day with no significant difference between species. This is the part that we're going to look at today. We're going to redo their work to see whether or not we think there's a significant difference. And I say today, but we're not actually going to be able to tell if it's significant today, but we're just going to start exploring the data. And when it says no significant difference, that's telling you they did a hypothesis test. And then you can pause and read through this. This was saying this was only the first step to see if there was a difference between the two species. They looked at a lot of different things to see what would explain how far the elephants walked, and then also to see if how far they walked was associated with better health. So for now, we're just going to focus on the specific question about if the two species of elephants walked different average distances. So what is the research question? They want to know something like, and there's different ways you could word this. You could say they want to know sorry, my keyboard's not working. Is species associated with walking distance? Or you could word it as, do Asian and African elephants walk different amounts? It didn't say anywhere that we read if they thought one would walk the other, so we're just kind of saying, are they going to be different? So that's always step one. Step two of our process is design a study and collect the data. So the article says they randomly sampled female adults from each of the 30 zoos. Now you might ask, why did they only look at females? Well, maybe there's a difference on how far they walk based on gender, and they didn't want gender to be a confounding variable, so they only looked at females. And they used GPS tracking devices for 5 non-consecutive days, at least 20 hours outdoors, and they recorded the mean distance for each elephant for the 5 days. So it makes sense to do non-consecutive days, because if you don't want the elephant to maybe been like sick or tired or something, maybe that would affect them for 5 days in a row. But if you do 5 non-consecutive days, then you probably get a better glimpse of their overall behavior. Okay, and here's a link to the data set. Let's see, so first, what were our observational units? Our observational units were the elephants. What's the explanatory variable? Now, usually our explanatory variable, if we're comparing two groups, is going to be our grouping variable. So in this case, what we're using to explain it, we're trying to look at the species. And in this case, it is categorical. And specifically, binary, there were only 2 options, African or Asian. And the response variable is the walking distance. And that was in kilometers. And the walking distance is quantitative, it's numerical data. Now, step 3 of our 6-step process is to explore the data. Now, the article included this graphic, and I put it in here to show you. Sometimes people do something like this. But notice this is not a histogram, and it is not a good way to display the data. Okay. So they put the elephants down here, and they ordered them from least walking to greatest walking distance. And you can see that there were some lower walking distances, around like 1 or 2, and then a lot of people, and it's like maybe 4 to 6, and there's one elephant that walked a lot, like 17.3 specific. And they did put in black bars for the African and gray bars for the Asian, but looking at this, it is really hard to tell, like, is the African higher, is the Asian higher? This is just not a good way to display our data. And they also had in the paper underneath this that the numerical summary was elephants walked an average of 5.3 kilometers a day. But our research question that we're interested in is, does the species affect how far they're walking? And from that, I can't really tell how the species is affecting, or maybe not affecting, but associated with the walking distance. Okay, so we're going to make some better graphics. We're going to open up the ISI applets. We're going to go to quantitative and descriptive statistics. So I'm going to come up and follow this link to get the actual data. So I have my data here. You can see there's the distance in kilometers, and then there's the species. I go to quantitative descriptive statistics. And I need to copy my data. So I just do Control A and Control C to copy everything. And I paste it in here. I click Use Data. And you should see this dot plot. Okay, this is a dot plot for all of my elephants. If I wish, I can click on histogram and see the histogram for all of the elephants. So that's what we have here. You could kind of tell that it's mostly symmetric, except for this one maybe outlier. It looks like we're fairly centered around this 5. You can decide whether you like dot plots or histograms better. For small sample sizes, as I go on, I actually like dot plots more and more, okay, but you can pick which one you like better. Okay, but our research question wanted to compare the walking distances between the species, and from right now, I can't tell you anything about the two species. So what we're going to do is we're going to come back to our applet. And in the applet, I'm going to say right here, my quantitative variable is distance. You can choose which variable you're looking at. And then I'm going to separate it by species. And now, automatically, it will give me 2 different histograms. And I can look at the histograms, or I can look at the box plots. So now, looking at these histograms, here's my Asian elephants. Here's my African elephants. So I have my African ones and my Asian ones. Now, just looking at these 2 histograms, is it obvious to you which group walks farther? Well, we do have this one that looks like an outlier that's way up there. Okay, but if you kind of ignore the outlier and you only look at the main data sets, I can't really tell. Like maybe African's a little bit higher, but maybe on average, but they look fairly similar. So I'd say no. I can't really tell for sure. So we might want some more numerical ways to look at these. So box plots are another way to visualize quantitative data, numerical data. We start with our 5-number summary. Hopefully you've done this in another class before. The minimum is the smallest data value. Your first quartile is the data value that has 25% of observations less than it. The median is the data value that has 50% of observations less than it. Sometimes this is called the second quartile. Okay. And the third quartile is the data value that has 75% of observations less than it, and the maximum is the biggest data value. So basically, if you think about like all of your data, you divide it into 4 pieces. So the median cuts it in half. This is your minimum, this is your maximum, and then you cut it in half again. So this is 25%, this is 50%, this is 75%. So 25% to the left, 50% to the left, 75% to the left, and then your maximum would have like 100% to the left. So you're dividing your data into 4 chunks. That's why they're quartiles. And then to make your box plot, the box plot goes from the first quartile to the third quartile with the median marked in the middle, and you have whiskers that go to your minimum and your maximum. Now the width of the box itself, so from here to here, from the third quartile and from the first quartile to the third quartile, it's called the interquartile range. So you just subtract the 2 quartiles, that's your interquartile range. It's the width of the box. So interquartile range is a way to measure the spread or variability of data. It is an alternative method to using standard deviation. It's not that we should always use one or the other, it's just an alternate. You can also graph individually any outliers that are more than 1.5 interquartile range from the edge of the box. Okay. So you figure out where the third quartile is. If any points up here are more than 1.5 quartiles away, then they get marked separately. Okay. And then the whiskers just go to the last non-outlier. I'll show you picture of that. So if we go back to our elephants in our applet, you can click Add Box Plot, and it'll show you the box plot for each. And then so these are our box plots, but you can also click this Show Outliers. And notice my whiskers tend to kind of disappear a little bit, and you get individual points marked. So that means like these are outliers, or these are outliers. They are so far away, they're more than 1.5 quartiles away from the edge of the box, and so they get marked separately, and that just helps you find outliers quickly when you look at a box plot. They're not always marked, sometimes they're marked, sometimes they're not, okay, but software will give you that option usually. So let's use the box plots to estimate each of the following. So let's look at African elephants first. So up here, this box plot, and let's estimate the minimum. So I think the minimum is going to be about, so it's somewhere about 2. I can't tell exactly, and I'm not going to make you be this exact on the homework because I think it's wrong to make you spend that much time on meaningless work. But when you have the dot plot, you can come and you can click on an individual point, and it will tell you that that was 2.2. So guessing, I think that was about 2-ish. I can also tell looking at the plot that it was 2.2. Now let's look at our first quartile. So that would be the edge of the box here. So I think that's about maybe 4.6. Now for my median, let's try and go straight down from my median. Looks like that should be, I didn't go very straight, a little over 5, so 5.4. My third quartile, going down, that's maybe like 6. Okay. And my maximum is about 10, maybe, guessing. I could come back to my applet. I could click on my last point here, and it's 9.7. I'm going to say 9.7. Now, here I said we're just estimating on the test. It's just estimating. You don't have to be that exact. I'll make sure it's multiple choice so you can make sure you get the right answer. Okay. But on the applet, okay, you can come and you can ask for the actual mean, median, standard deviation, interquartile range. Okay. And it will give those to you. The mean and standard deviation will be red, median and interquartile range will be blue. Okay. And so I can see, okay, my median was 5.4. Okay. My interquartile range, that means this is your third quartile. And this is my first quartile. For the interquartile range, it shows you what numbers they're subtracting. So that means my third quartile was 6.05. So we could adjust that here. Then if I want my interquartile range, you just subtract the third and first quartiles. So 6.05 minus 4.6 gives me 1.45. So it's kind of like a standard deviation, not exactly the same, but similar. It's just a way to describe how spread out your data is. Okay, and then the shape of the distribution, I want you to tell me if you think that it is symmetric or skewed. Okay. Let's see, if you look at this dot plot, it looks like it's kind of maybe almost symmetric, except for these kind of make it look like it's right skewed. Okay. And if you took this box plot and you divided it in half, this side seems like it's a little bit longer. Okay. So I think it is very slightly right skewed. So now let's look at our Asian elephants. So now for our Asian elephants, we can see where they start. And I'm going to guess about 1, maybe. And my first quartile looks like it's about maybe 2.8. My median, just a little bit over 5, maybe 5.2 if I cheat and look. My upper quartile, that's about 7-ish something, maybe 7.4. And my maximum, that's maybe like 17. Okay, I could go and look at the data if I wanted to know for sure. In fact, I happen to remember it's 17.3. Again, on the test, you're just estimating, so you don't have to be this exact. For your interquartile range, you just subtract the third and first quartile, so 7.4 minus 2.8 which gives me 4.6. That tells me that my Asian elephants are much more spread out than my African elephants. Now, you might not have thought that when you just looked at all of the data overall. Okay, if you look at the entire box plot, like, okay, the Asians are a lot bigger, but I like to look at the inner quartile range, the actual box. You can see this box is much smaller than this box. So like most of the data that's kind of in the middle is much more compact for the Africans and much more spread out for the Asians. Now, if you want to know if it's right skew or left skew, you can divide it in half. Okay, and which half is longer? This half is much longer. Okay, and so it is very right skew. So I have a note here. You can tell if the data is skewed by looking at the whiskers. So we kind of divided in half and looked at the whole half. You can do that, but that was harder to think about how to describe it to you. So you kind of have to just look at the whiskers. If the whiskers are about the same length on both sides, the data is symmetric. If the right whisker is longer, so this right whisker was a lot longer, the data is right skewed. If the left whisker is longer, the data is skewed to the left. So let's interpret the quartiles just so we know what they mean. So the first quartile being 4.6 means that about 25% of the elephants walked less than 4.6 kilometers a day. Okay. If the median is 5.4, that means about 50% of the elephants walked less than 5.4 kilometers each day. And the third quartile, that's 75% to the left, less than it. So about 75% of the elephants walked less than 6.05 kilometers each day. So that's what quartiles tell us. They just divide our data into 4 chunks. So the first quartile has 25% of the data to the left than it. Okay, what if I ask you something harder, like the top 25% of Asian elephants traveled more than what kilometers? Well, if you think about it, if we take our data and we divide it into 4 chunks, okay, where are you going to have your top 25%? That's going to be here, from your third to your maximum. That's going to be your top 25%. So for your Asian elephants, the third quartile was 7.4. So that means the top 25% of Asian elephants traveled more than 7.4 kilometers each day. Now, let's go back up and look at the 2 species distributions and compare which ones had the higher median, mean, interquartile range, and standard deviation. So you can try and do this just looking at the box plot, or you can actually look at the numbers. Okay. For mean, it is really hard for me to see mean on a box plot. I can guess that it's probably going to be somewhere by the median. I can maybe guess if it's going to be pooled a little bit. So, for instance, when we look at the Asian elephants, I might guess that my mean will start off here by my median, but because it's very right skewed, I know that my mean will get pulled up a bit, so maybe it's a little bit more than like 5. But again, I can't really tell you that just looking at it. So for the mean and standard deviation, I'm just going to look at the actual numbers. So the African elephants walked a little bit farther on average, and their standard deviation was much smaller. There was much less variation. So Africans walked a little bit farther, but for standard deviation, it was Asians were much more spread out. Now, coming back up at the box plots, I might ask you, just looking at box plots, to tell me which one has a higher median. So looking at the box plots, you can see that the median is a little bit higher for the Africans, but for the Asians, it is much more spread out. The interquartile range, if you look at the actual box, is much more spread out for the Asians. So African was slightly higher. But the Asians had a much wider box. So a much higher interquartile range. Let's see, we might want to know how do outliers affect the distribution. So we can actually use the applet to remove the elephant that walked 17.3 kilometers from the Asian elephant data set. Okay, because that one was so far up there. When you look at the data set with it, this 17.3 is just so far away from everything else. Okay. So we go to our applet. You can click on the individual point. It'll tell you Asian 17.3, and you can delete it. Okay. And then everything will update. You can see your new box plot. You can see your new median, interquartile range, your mean, everything that you have selected. So let's look at them. How did it change? My mean went from 5.2 to 4.7, so it decreased a lot. Okay. The median went from 5.2 to 5.15. That didn't change very much. It's almost the same. The standard deviation went from 3.4 to 2.2, so it decreased. And the interquartile range was 4.6 to 3.9. Now, usually, it doesn't change very much. This was just happened to affect us a bit. So usually doesn't change, but did slightly. The reason it did is because when we delete this last point, it changed how many values were in our data set. And so sometimes when you're finding like a median or a quartile, you either pick a value or you have to take the average of two values. Okay? And so basically it just changed which value happened to be that dividing point. Okay? So the important thing to remember is that your mean and standard deviation, if you change an outlier, will usually change a lot. Your median and interquartile range usually don't change very much. And even here where it did change, it didn't change as much. Okay. Now the elephant that walked 17.3 kilometers a day is definitely an outlier. As a researcher, we should wonder why this elephant is walking so much. Is she anxious, sick? Was she older when she came to the zoo and used to walking long distances to find food? Was the decimal in the wrong spot? So it is unethical to just throw out an outlier. We should always investigate them, figure out what, see if there's actually like a reason that we should take them out because they're not like most elephants. Okay. Or we can do other statistical techniques that are better suited to work with outliers. So how do outliers affect the distribution? Means and standard deviations are always much more affected by outliers and skewed data. So sometimes when we have a skewed data set or outliers, it's actually better, or it could be better, to analyze the data with medians and interquartile range than with means and standard deviation. But those techniques are more difficult and we don't actually teach them to you in this class. And our last objective for today is to compare two distributions to see if the variables are associated. So if the means or medians are different for our different groups, then the variables are associated. Of course, even if the population means are the same for our groups, we'd expect the sample means to be different just due to chance variability of who we pick to be in our sample or who we put in each group if we're doing an experiment. So in the next sections, we'll learn how to actually tell if the difference is statistically significant. But what we're going to do here is we're just going to guess whether or not we think the variables are associated, just looking at the box plots by eye and looking at the mean and medians. Okay. So this first example is the time to sing the national anthem by gender. And when we look at this data set, I can see a few things, like my medians seem to be fairly different for these two groups. Like our medians go from 95.5 to 114. That's a difference of almost like 20. That seems pretty big. And if you compare 20 to the interquartile range, it's almost a whole interquartile range. So that is fairly different. They look like they're fairly similar, though, as far as the amount of spread. What else can we see? Our mean is 98.4 for males and 112 for females. Again, that's the difference of maybe like 15 or so. That's almost a whole standard deviation. If your difference is almost a whole standard deviation, that's probably going to be fairly surprising or fairly different. So here I would guess that there probably, or is probably, a significant difference. I can't tell for sure without actually running tests, but I think it's probably significant. So I think they're probably associated. Or let's actually write that out a little bit better. Let's say that we think that the gender and time to seeing are probably associated. Now, when we look at this other data set, this one, if I look at them, my ranges or my variability seems fairly similar. This one might be a little bit more spread out, but fairly similar. Okay. But your medians, though, are so different. Look at this, like your box plots don't even overlap at all. So up here, our box plots did kind of overlap, but at the same time, like this median lines up more with the first quartile. Like that's fairly different. Okay, I feel like this whole box plot shifted over quite a bit. But here, we don't even overlap at all. Like this one, we are definitely different. And if you look at the actual numbers, my median goes from 15 to 5. That's a difference of 10, and my interquartile range is only 2. So our difference is like 5 times bigger than our interquartile range. That's huge, okay? Or your means go from 15 to 5 versus your standard deviation is 1.4. Like that's just a huge difference. So this is a huge difference in means and medians. We are definitely a significant difference. Okay, so the variables are definitely associated. I don't even have to do a test to know for that one. So let's keep looking. Okay, if we look at the elephants, okay. Well, now that we've looked at some others, these start to seem a lot more similar. So here's my medians, and they are off a little bit, like from 5.4 to 5.2, but that's only a difference of 0.2. And notice how big are our interquartile ranges. Our interquartile ranges, if are 1.4 and 4.6, that's a lot bigger than a difference of 0.2. Okay, or if we look at our means from 5.4 to 5.261, that's only a difference of 0.15 versus our standard deviation of 1.5. Our differences between the means and medians seem very small compared to the spread. So the difference between the means or medians seems small compared to the spread. If you look at these two box plots, they really overlap completely. Like one's not even higher than the other one. I feel like there's probably not going to be a significant difference here. So I'm pretty sure there is not a significant difference. Okay. The slight difference we see is probably just chance variability. And I can say that the variables of species and amount walked are not associated, is my guess. Okay. And we will actually find the p-value later, and we'll find out for sure that they are not associated. Let's see, number 4. Looks like we have 2 more box plots. Again, they seem like they're in fairly similar locations. This spread is a little bit higher for the male group. Okay, these are weights of backpacks divided by gender. But except for that spread, if you ignore the outlier, so ignore that outlier, they'd actually look very, very similar. Okay, I'm guessing that they're same thing as the elephants, that they're probably not associated. I think that difference probably isn't very big. If you look at the means, we're off by about 1.5, but my standard deviations are 5 or 6. So that difference seems very slight. Okay. And if you look at your medians, from 11 to 10, that's a difference of about 1, but my interquartile ranges are 6 and 8. So I think the difference is probably just chance variability. I don't think that these two variables are going to end up being associated. So we can write very similar things of the differences in the means and medians seem small compared to the spreads. So these variables are probably not associated. And on the homework, we'll have you practicing. Do you think that they're associated? Sometimes you can tell I really don't think these are associated. Sometimes you can tell they are definitely associated. Sometimes you have it like this, and you're like, Probably, I'm not really sure until I actually do a test.